keep distributing. 2 times a is 2a. 2 times negative 3, negative 6. Yes, we wrote this on the back of our notes. So these are on the back of 8.1 notes. We're going to add 6. 2a equals 46. Divide by 2. And a, ooh, that's an ugly a. A equals 23. Yep, and then the second, it's the same idea. We're just going to practice again. Do you want to distribute the n minus 9 or the n plus 5 first?
9.
The 9? Okay. So again, you're going to multiply 4 times n minus 9. I wrote it in front because people prefer it that way. It doesn't matter what order you multiply in. Think of like 1 times 2 is 2. 2 times 1 is still 2, even though you flipped it. So it doesn't matter. Same thing the other way. We'll have 7 times n plus 5. So you'll make sure you distribute. So we have 4n. 4 times negative 9? Negative 36. 7 times n? 7n. And 7 times 35. Sorry. Yeah, well, there's that. All right, subtract 4n. Minus 36 equals 3n plus 35. Subtract 35. What is negative 36 minus 35? Negative 71. It is an ugly number, and it's just going to be ugly. Divide by 3. Does 3 go into 71? No, we're just going to leave it. That's it. Ta-da! Yeah, just like that. It's ugly. It doesn't reduce or anything. It's just ugly. This is improper. It's fine. We've never made it mixed. Is that what you mean? Yeah, no. Go ahead and go to page 4. You said... I'm getting there. Right? You said we did do the gazebo question, or we did not? We did do the gazebo question. So just to remind you, perimeters are proportional to the sides. So we did this question. That left us here. Wonderful news. All right, so what you need to remember in similar perimeters is that side 1 over side 2 is proportional to the perimeter of the first over the perimeter of the second. So let's look at what we were given. The perimeter of one polygon and the ratio of the corresponding side lengths is given. What does that ratio look like?
A fraction.
A fraction. So in the instructions, they called it the ratio of the corresponding side lengths. In the bottom, they called it a scale factor. They're actually the same thing, and they represent the fraction that the side lengths are, the ratio of them. So we're going to plug in 3/4 for the sides, because that is the ratio of the side lengths. And this is called the ratio of the side lengths. Are we tracking a little bit? Ratio is a fraction. The fraction of the side lengths is 3/4. The only thing that you have to do is figure out where this perimeter goes, where 12 goes. So let's take a moment to look and see 3 and compare it to 4. We are going to have a smaller shape and a larger shape. All right? The ratio of the side lengths is 3/4. Which shape is going to have a perimeter of 12? Is it going to be the smaller or the larger? The smaller, that has the 3. So the 12 is going to go across from the 3. Is everyone tracking that? It is the smaller perimeter. It goes across from the smaller side length. And then do we know the perimeter of the larger shape? No. That's what it's asking for. It says find the perimeter of the other polygon. So the larger is what we're looking for. So this is how we have set up our problem. And then we solve. Cross multiply. 3 times x is 3x. 4 times 12 is 48. Divide by 3, and x is 16. And it is feet.
Didn't you just add up all the fours in that big polygon, like the fours that
You don't know that it's you don't know it's a square. I just drew a shape. He asked if you could add 4 times. We don't know that it's a square. It could be any shape in general. I just drew. All right, we're going to do the same thing. Okay. Side 1 over side 2 equals perimeter of the first over perimeter of the second. What's the ratio of the side lengths this time? 6 over 5. So again, I'm just going to sketch 6 and 5 are the ratio of the side lengths. So which one of them has a perimeter of 72 inches?
Larger one.
The larger one, which is 5 larger than 6? See how it says the larger polygon?
6.
Well, I was talking about the shape. So, well, the larger polygon has a larger perimeter. So you're going to put 72 across from the larger number.
Oh, so it's a bigger, not a bigger shape.
Oh, yeah, I'm sorry. It's not drawn to scale. My B.
Yeah, see?
Sorry. He's confused because I made this smaller than this one. My B. Is everyone okay with why we put 62 across from the larger number? Or 72 across from the larger number?
Yeah, you messed my brain.
Okay. All right, so we cross multiply again. I'll re-explain it a different way in a second. We have 6x equals 5 times 72.
Oh, you're on 360.
360. So then x equals 60, and then I think it's inches. All right. So here's another way to make sure that you are putting this in the correct place. You see how we said that these two things were equal? The only way for them to equal is if this reduced down to 6/5. Is it possible for it to reduce down to 6/5 if the bigger number were on the bottom instead of on the top? It would not. So across, that's not the highlighter, across needs to be the bigger number. Across on the bottom needs to be the smaller number. The same thing over here. We were given the smaller perimeter, so it needs to be across from the smaller number. The bigger perimeter will be across from the bigger side length. That's the pattern that we used. When you're ready, we're going to turn to the next page and do area. Area. So area is the same formula. Go ahead and highlight the box in the top right. So highlight the box in the top right. And we're going to fill in the formula that goes there. The formula is the same except for, if you look, what is happening to the sides?
Squared.
They're being squared. If you look down here, side from the first, side from the second, squared. Area of the first, area of the second. So go ahead and write that in that box you just highlighted. So side from the first over side from the second, squared, equals area of the first over area of the second. The people that get this question wrong, they don't square the sides, which will change your answer a lot. So the ratio of their areas is equal to the squares of the ratio of their side lengths. Sounds really complicated, but it is not. Is the rectangle first? Yeah. All right, so we're going to write down the formula. Side from the first over side from the second, squared, equals area from the first over the area from the second. You do want a calculator. I don't think you want to square some of these things. But what is the side from the first shape? 7. So a side from the first over side from the second. So what's the second? 21. equals the area of the first, which is 84. And our whole goal, it says the rectangles are similar. Find the area of LMP. So do I know the area of the second? I do not. So we can call it X, or you can call it A for area, however you would like to do it. All right, and then we're going to talk about squaring a fraction. When you square something, what are you doing to it? Multiplying it times itself. So I'm going to show you what you're doing and then show you how to shortcut it. So essentially you're multiplying 7 over 21 times itself, right? So you don't have to write it off to the side. You can just square the top and square the bottom because it's the same. When you multiply straight across, right? So you would be doing 7 times 7, which is the same as 7 squared. And then 21 times 21, which is the same as 21 squared. Is everyone tracking there? So that's what we're going to do. 7 squared is 49, and 21 squared, 441, equals 84 over X. Cross multiply, we get 49X equals a large number. What is 441 times 84? 37,044. So 37044. Divide by 49. What is the area of the second shape? 756 meters squared. All right, which makes sense because shouldn't the area of this rectangle be much larger than the area of this tiny rectangle? I will tell you, you could have taken this and reduced. What does 7 over 21 reduce to? 1/3. If you're good at reducing, go for it. If you're not good at reducing, then don't go for it because it will mess up your whole problem. You still would square it. What's 1 squared? And 3 squared? And it equals 84 over X. Guess what 9 times 84 is? 756, which is the answer. All right, you're going to do the next one. Go. I can see you all are doing great, staying awake. You're on your own. You need to write centimeters, or was it centimeters squared? And then you write centimeters squared. All right, so you should have plugged in like 10 over 5 squared equals 36 over the area. And then what did we get for the area of the smaller triangle? 9 centimeters squared. Perfect. Go ahead and turn to the last page. We're caught up with where we were supposed to end. So we're going to do the same thing here, except for there's going to be something else missing. Your test next week is very short. It's about 17 or 18 questions. Either honors is 17 or yours is, I don't remember. Your test on Thursday, it's chapel day. So all the other classes have shortened class periods. So anyways, you'll have one of each of these. So this is 2 out of the 17 or 18. Just for you to know if you want to put a star next to it. The figures are similar. We're going to find the missing corresponding length. We're going to use the formulas to do that. Which formula are we going to use for the first question? The perimeter. This is perimeter. So we're going to use the perimeter. So side 1 over side 2 is equal to the perimeter of the first over perimeter of the second. So we're just going to read and figure out where these numbers go. It says figure A has a perimeter of 60 inches. So where am I going to put the number 60? P1, correct. Top right. And then one of the side lengths is 5 inches.
That's
S1. That's the side that corresponds with figure A. Figure B has a perimeter of 84 inches, so P2. So we do not know the other side length. You can call it X, you can call it S, you can call it whatever you please. Then we just cross multiply. So we have 60x equals, what is 5 times 84? 420. And then divide by 60. X is 7. And you'd put inches. That's it. The second one, which formula are we going to use? The area formula. So side 1 over side 2. What's happening to the sides? Squared equals area of the first over area of the second. All right, so it says figure A has an area of 4,928 feet. So that is the first area, area 1. So 4,928. And then one of the side lengths is 88. Yeah, correct. First side. All right, figure B has an area of 77 feet. A2. Do we know the other side lengths? No. This is going to be a large answer. Just prepare your heart. What is 88 times 88? Seven 7,744. So we've squared 88 squared, but remember you also have to square the bottom. So you'll have x squared on the bottom. And then I'm just going to copy over the right side. We didn't do anything to it. So we still have 4,928 over 77. This is why I said this is going to get large. So we have 4,928 x squared. That's wonderful. Across from it, we have 7,744 times 77, which is... Is it? I don't remember that number, but that's okay. If there wasn't a squared here, what would you do to solve for x? That's the same thing. You're still going to divide by 4,928 on both sides. So what do we get? Correct. So we still have x squared equals 121. Did we get x by itself? What's happening to x? It's being squared. What is the opposite of squaring? The square rooting. So not dividing by 2. It's not the same thing. Take the square root. You're trying to figure out what times itself is 121. 11. So 11, and we'd say feet. No, good question. It's a length. We just found a side length. Good. So now, 8.3. It's short. I know it doesn't look short because it has a staple, but we don't go through all of it. We go through the first page and half of the second page. All right, so we're going to see if triangles are similar. This is why you need 2 to 3 highlighters, because there's a lot of black and white. So, before we talk about this, what makes any shape similar?
Same shape.
It has to be the same shape, yes, but what else? The sides have to be proportional. What else? Proportional. What else?
Congruent?
What has to be congruent?
The sides have to be angles.
The angles have to be congruent. Angles have to be congruent. All right, so you don't need to know all of that to figure out if a triangle is similar. You can just know that the sides are proportional, and that's enough to see if the triangle is similar to a triangle. So we're just going to figure out if the sides are proportional in this section. Because if 2 triangles have proportional sides, then the triangles are similar. So do you remember when we wrote this? Statement of proportionality? We're going to do that, but with the numbers. And then see if the sides are proportional. All right, so here's why we're going to use the colors. There's a lot of black and white, and it's so much easier in color. We are deciding if either DEF, which is this triangle, or GHJ, which is this triangle, is similar to ABC. So one of them will be similar to ABC. We are going to figure that out by finding the scale factor of the sides and then seeing if the same scale factor is there. So you're going to take one color. We could start with AB, highlight AB. We're going to highlight all of the sides that correspond with AB. So which side in DEF corresponds with AB? DE. Let's go ahead and highlight. It's the number 6 there, if you. And then what does it correspond with in GHF? Sorry, GHJ. GH. Good. Take your second color. We can do BC. What does BC correspond with in DEF? EF. And then it corresponds with HJ in GHJ. This is why I said you need 2 definitely, because if you don't have a third highlighter, you could just be unhighlighted. They correspond. If you have a third highlighter, you can just run through really quick and highlight the remaining. So the first thing we're going to do is figure out if ABC is similar to DEF. So we're going to ignore the third triangle for a minute and figure out if these 2 are similar. So which of these is the original triangle? ABC is the original. We can call this the old triangle, which means DEF is possibly the new triangle. We want to figure out the scale factor to figure out if they're proportional. The scale factor is the new length over the old length. So that's what we're going to do. Let's start with AB and DE. So AB and DE. Which one is the new length? 6. And we're going to put it over the old length, which is 8. This reduces to 3/4. So we want to see if all of the other sides have the same proportion, if they all reduce down to 3/4. Let's do BC, which is 12 and 9. Which one is the new length? 9, and then the old is 12. What does that reduce to? 3/4. Keep in mind it's called side, 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 so we need to know all 3 sides just in case. All right, and then which one is the new length, 16 or 12? 12 over 16, which reduces to 3/4. So are all of the sides proportional? Do they all have the same scale factor? Yes. So these 2 are similar to each other. We're just going to write that down. Triangle ABC is similar to triangle DEF. And that's actually the end of this question. The reason is it says is either, so it's one or the other. It was either DEF or it was GHJ. And we figured it out before doing more work. And we're in the business of doing the least amount of work possible, yes? So be good. We're going to do the same thing below. It just looks a little different. These are two separate questions, 1 and 2. They're just using the same original triangle. So this is the old triangle. We're going to do number 1 first. We're going to see if the old triangle was multiplied by the same number all the way around to get the new lengths on this triangle RST. So let's take our highlighters and do it again. We have AB, which is 6. What does AB correspond with? RS. Oop. And then BC corresponds with?
Yes.
Correct. So again, if you don't have a third color, you can just leave it unhighlighted. But we're figuring out if these two are similar to each other. They either are or they are not. All right, so pick two sides, any two sides. 2.5 and 4. All right, so we want to figure out the scale factor that turned 2.5 into 4. So remember, you do new over the old. So what is that fraction going to look like? 4 over 2.5. This isn't super helpful because this is a decimal and we can't really reduce it. What we can do is make it a decimal in general. So go ahead and do 4 divided by 2.5. What is it? It is not 10. You multiplied it. What is it? 1.6. So we want to see if all of them have that same scale factor. Which two sides are we going to use next? Sounds good. So which one would go in the numerator? 7. And then in the denominator? 5. What is that as a decimal? 1.4. So this is a no. This is not similar. You can write the statement and put a slash through it if you want. Some people do that. All right, and then the last one on this page, the last one we're going to do that's like this, we're going to see if ABC was turned into RST. So again, you want to go through and highlight the sides. AB still corresponds with RS. CA corresponds with TR. And then BC corresponds with ST. The other recommendation I would have, do you see how this is a fraction, 12 over 5? Would you like to put a fraction in a fraction? I didn't think so. We could change it into a decimal so that we can actually figure out what it is. What is 12 divided by 5? 2.4. Perfect. So we'll use the 2.4 instead of the fraction. Do you want to do that one first? Just get the ugly one out of the way. So which number would go in the numerator, 6 or 2.4?
So 2.4.
You want the new one? 2.4 over 6. All right, pick another two sides. 2 and 5. So which one would go in the numerator? 2. Oh, I forgot to keep going. Sorry. This is another decimal in a fraction. We can just make this into a decimal. What's 2.4 divided by 6? 0.4. And then what is 2 over 5 in a decimal? 0.4. Things look promising. Let's check the last one. So we have 2.5 and 1. Which one will go in the numerator? 1 over 2.5. What is that as a decimal? 0.4. Which means, don't turn yet, I'm just going to show you something. Which means triangle ABC is similar to triangle RST. Let's notice some things. Do you see how 2.4, 2, and 1, they all come from the same triangle? The same thing with the bottom row. 6, 5, and 2.5 come from the same triangle. Just make sure you're being consistent when you're writing the proportions. Okay, straight across should come from the same shape. We have one more to do together. And we'll hopefully play a game. Let's look it. All right. Find the value of x that makes this. What does this statement say? They're similar, right? So what do we know? X is a side. What do we know about sides in similar shapes? They're proportional. So similar, we'll say triangles, have proportional sides, if I can talk. Proportional sides. Why does this matter so much? Well, you're my 5th class of the day, and I'm going to tell you right now that it's not like resonating with students and they're doing a lot of problems wrong because they're not setting up a proportion. Here's what I mean by that. We see x minus 1, right? What does it correspond with on the other triangle? EF. Are they equal in length? No. So should I set them equal? Because they do not equal. The same thing with this x, 3 times x plus 1. Is it the same length as 8? No. So you cannot set them equal. You have to set up a proportion. However, we can just pick one of them to work with. Which one would you like to deal with? I usually pick the easier one. So which one would you like to work with? We have to solve for x. So I'm asking which x would you like to solve for? Yeah, we're going to use x minus 1. So x minus 1. What does it correspond with on the other triangle? 18. And it equals, so remember we really don't want to use the other x, which means we really don't want to use 8. So we're going to use 4. And we're going to use 12. So again, notice straight across, x minus 1 and 4 are from the same triangle, and then 12 and 18 are from the same triangle. So it should always be like that. Now we just cross multiply. This is why we practiced it earlier. When you have x minus 1 times 12, you have to make sure you distribute the 12 into x minus 1. What is 18 times 4? 72. So when you distributed, you should have had 12x minus 12. We're going to add 12. 12x equals 84. So then x equals 7.